Hi all, let's start. So guys, any questions on this? Any questions so far? Any questions so far, guys? So if you have any questions, please raise. If not, we'll start the class. Okay, let's start. So guys, today we are going to learn a concept known as Docker, guys. Right? Say the Docker and all, right? Say, first of all, let's see something about Docker. Why? We need to have Docker and all, right? Right. First of all, look here. This is the requirement for Docker and all, guys. Right. Now see here, this is the hardware is there. On top of the hardware, we have the operating system is running. Operating system is running. In the operating system, guys, can we install two versions of particular service? Say, for example, Apache, guys. Here, can we install Apache 2.1 and Apache 2.2? Is it possible, guys? Apache 2.2? Is it possible, guys? Can we install two versions? Can we install two versions? It's not possible, guys. We can't install two versions of particular software, right? So it's like right, installing two versions of Word or whatever software, right? It's not possible, guys. So that's what there's another concept pop up. The concept known as, guys, VM, right? Here, guys, in the VM, this is the operating system. Here we are installing the software known as hypervisor. Hardware is there. The operating system is there. Here we are installing the software known as hypervisor. Hypervisor software. Right? On top of hypervisor, guys, we can create the virtual machine. This is the virtual machine, guys. Virtual machine 1, virtual machine 2, and virtual machine 3. We call VMs, right? Say, for example, VM1. Isn't it? Then we have VM2 and we have VM3. These are the separate machines. These are the separate virtual computer, VM. Right? In this VM, we can install Apache, guys. Say here in this VM, right? Say, let me install Apache 2.2.1 is the Apache 2.2. Likewise, I can install different versions of particular software. Example, Apache or whatever software. Right? But here we can install guys. On top of OS, we can install two versions of software, two versions of particular software. It's not possible. So that's what there's a hypervisor concept. We have two hypervisors, hardware hypervisor as well as software hypervisors. So we have hypervisor, we have hardware hypervisor and software hypervisor. Right? Say the example for the hardware hypervisor is VMware EXXI. VMware EXXI. So the example for software hypervisor, Oracle VirtualBox, VMware Workstation. These are the examples for the hypervisors. You see here, you see this is the hypervisor. You see here, this is the software hypervisor, Oracle VirtualBox. This is the software hypervisor. On top of this hypervisor, we just install the OS. You can install Linux or Windows, whatever flavors you can install here. This is the software hypervisor. Okay. This is the hardware hypervisor, VMware EXXI. Hardware hypervisor means on top of hardware, we can install VMware EXXI, right? Say guys, on top of hardware, guys, we can directly install the VMware EXXI, right? Right? On the other hand, software hypervisor, we are installing on top of operating system, right? Right. So this is the VM setup, guys. VM setup. Here we can install two different versions in two different machines. This one is VM1. We go for Apache 2.1. This one is VM2. We go for Apache 2.2. Right? Right. Say you see here, if the particular hardware come with 10 GB RAM, 10 GB RAM, we can allocate the RAM size. Say for example, this one 2 GB, guys. This one we go for 2 GB. This one we go for 2 GB. This one we go for 2 GB. Say we can install another VM. This one we go for, it's also 2 GB, guys. 2 GB. Okay. There's a balance 2 GB is there. The balance 2 GB goes to this physical machine. Right? Goes to this physical machine. totally 10 GB guys. Right? This is how we divide the RAM. Or you go for 1 GB, 1 GB, 1 GB, right? Then you go for 8 machines, 8 VM. If you go for 2 GB, you just go maximum 4 VMs guys. VM1, VM2, VM3 and VM4, right? So we have divided this RAM size among these machines. 2 GB, 2 GB, 2 GB. Now, there's a question here. There's a requirement to prepare 50 VMs, guys. VMs. Each VM should have 1 GB, guys. Each VM should have 1 GB. Then we need 50 GB, guys. We need 50 GB. Right now, we have only 10 GB, guys. So there's a shortfall, right? There's a memory luggage. Then the particular requirement is not fulfilled. We can't cater the requirement, guys. Our need is 50 GB, guys, but right, we can't afford that 50 GB RAM, right? Because right now we have only 10 GB, guys, right? That is one drawback, right? So here the second drawback, see, is one drawback, right? Second drawback is, say, now let's see, we have allocated 2 GB for the particular VM1. Here we install Apache. Apache users, say Apache users, guys, 0.5 GB Apache users. So see the balance, what is the balance part? Say 1.5 GB RAM size is waste, guys. This much of RAM we are wasting. 1.5. The Apache users only 0.5 GB, say for example, right? So this 1.5 we waste, guys. It's a waste. Okay. So then how can we manage this RAM? Right? There's a issue here, guys, memory management. Memory management issues there. Okay. That is a second issue. Third issue, right? In VMware and all, there's a technology known as memory reclaim technology. Right? Memory reclaim, right? So in this VMware and all, guys, this technology is not fully stabilized. That means, say, when you shut down the particular VM, it will take more time to release the RAM to OS. It will take more time to release the RAM to OS. It takes more time, right? Memory reclaim technology is not stabilized, right? So because of this reason, guys, because of this reason, there's another concept pop up, the concept known as Docker. Then people move to Docker concept. Right? Say Docker is something like this. This is the hardware. This is the hardware. Hardware. On top of hardware, we have operating system over there. Operating system. On top of OS, we are installing the Docker software. So here we are installing the software known as Docker. On top of Docker, we are configuring the containers. The special word, guys, containers. This is not VM. So these are the Docker containers, right? So the setup is like this. Let me show you here. You see here, this is the hardware infrastructure. On top of hardware, we have the operating system. On top of OS, we have the Docker. Here, we have the Docker, guys. Okay. We can go for a Node.js, MongoDB, a Debian, Ubuntu, Red Hat, whatever it is. Say we can go for web servers, database servers, messaging, orchestration, whatever it is. Right? Right? On top of OS, we install the Docker software. Here, on top of Docker, we have the containers. See, these containers are floating, guys. Floating over the water. See here, let me show you. Say just type Docker. You can see the Docker symbol. This is the Docker symbol, guys. You see here is something like this. The Docker symbol is like this. Did you see the picture? Say the Docker symbol is like this. Say this is the Docker container. Docker container. Say container means say something like small boat, right? Sorry, Docker is a small boat, guys. Right? Docker is a small boat. In this boat, it carries many containers, right? Say MySQL container, web server container, blah blah things, right? Say you see here, so it carries different containers, and you see here, this is the web server container. It's a database server container. messaging, orchestration. See here, if you take one container, if you take this one here, we have only libraries and dependencies. See here, Docker is there. On top of Docker, we have containers. Right? Containers. Say here, say we have containers. Say containers means here guys, we have something like this. Say for example, there's a library is there, and there's a dependencies, and say and the particular software, say for example, Apache or something. So Apache 2.1 or something, right? These images are the Docker images are small in size, guys, very small, right? So these are the containers. Now you may ask, how do we create the containers, isn't it? How do we create the containers? We can create the containers from Docker images. From the Docker images, guys, this is called Docker images. From the images, we can create these containers. We can create these containers. Okay. The image is a static thing. It won't run. Containers will run, guys. Containers will run. These images come with, say, libraries, dependencies, and the software. It only comes with only one service, say, only the web service, Apache, only the database service, say, SQL, sorry, MySQL, or what, say, Node.js, only one service, right? Say only one service. Say it has a library and dependencies. So these images are small in size. Say for example, less than 100 MB. Right? Say once you call the images and you can run the images. When you run the images converted to containers. Guys. The images converted to containers. So the containers. The containers can run, guys. Containers can run. Images won't run. Can't run, guys. That's what we are converting these things to containers. You can install the Red Hat. You can run Ubuntu. You can go for Debian. Right? You can install SOC or Apache, whatever thing, right? See, these are the containers. See, these containers uses the same kernel. These containers, guys, uses the same kernel. Say whatever Linux flavor, the kernel is same. Right? Say, see, this one is the hardware. Only one computer you can run many computers, right? It's a Red Hat, Ubuntu, Debian, SUSE. All these containers uses the same kernel. The kernel is same, guys. Right? Say guys, say here we are running the 10 GB RAM. We have allocated 10 GB RAM for this bare metal, this hardware. Here we are running the Apache 2.1 we are running. Right now, this Apache uses say 0.5 GB. Just for example, it uses or it takes 0.5 GB. If there's any requirement, to go for 1 GB, guys, 1 GB, then the particular container contact to operating system and get the RAM, right? If the need only, or if there's any requirement, right, then this container contact the operating system and get the RAM for 1 GB, right? Again, if the requirement is 0.5 GB, then the container automatically release the RAM to OS. Then other containers can use, right? This is how the containers uses the resources. So here, if we want to go for more containers, say for example, 50 containers, we can create 50 containers, right? 50 containers. It also depends on the hardware requirement and all, right? Right? This is how the container works. These containers comes from the images. Now, you may ask where these images are stored. These images are in dockerhub.com. hub.docker.com. Say, let me check the site. So I think say hub.docker .com. So these images are stored in this site. You can download the images from this site. Right? Say, let me access this site hub.docker.com. Here, this is the site, hub.docker.com. Here, you can see number of images. Say if you type, let's type the image called Ubuntu. here you can see the Ubuntu images. Ubuntu is there, web share, blah blah things. Okay. Say I just logged into this site. You can create a free account in this site, guys. Go to docker.com. There, create a free account, and you can log in. So these are the free images, guys. Say Docker is there. Say CentOS is there. Okay. CentOS is there. Apache is there. Apache is there. Database is there. Okay. Likewise, you can download the Docker images. This is not operating system images. Huh? So these are the Docker images, right? Let me answer the question. Yes, I already explained these things, right? Let me answer that question, right? So VMs, guys, we have these sort of issues. Right? The memory management issues there, memory reclaim issues there. We can't create more number of VMs. So that because of this reason, we just move to Docker. Docker, here we have easily release the memory. We can, the Docker absorb only the needed memory, not like VM. Here we can create number of Dockers, right? We can create number of Dockers, not like VM, right? Because of this issue, we move to Docker. Okay. Right. Okay. Right. Okay. Fine. Sorry, I didn't see your question. Huh? Sorry. Right. Okay. Right. So this is the Docker images. Huh? Say Ubuntu is okay. You see the images are here. Just create the free account and log in. Here I logged as NetXperts. Right. Here you see number of images. You have free images and paid images. These are the free images, guys. Anyone can use. Docker, guys, there are two type of images. Say, let me show you. I think it's not here. Anyway, I'll show that one. Yeah. Docker, guys, two editions. One is community edition, other one is enterprise edition, W. So the community editions are free, guys. Enterprise editions are paid one, right? You have to pay and download the images, right? So these are the community images, guys. See, these are the community images, right? Right. Our practical also, we are going to use the free images, community images, right? Right. So there are two kind of these things, guys. Right. Now, right. Right. Here you can find the free images hub.docker.com. Right? Now see here, say you see here something, say process, network, mounts. And see here, say, see this, the containers use a separate pipelines to access the hardware or OS. Say, for example, guys, separate pipeline means, say here, say, look here, this is the flat. In flats, guys, we have first floor, second floor, third floor, like that. The floors are there, right? Here we have the water tank. This is the water tank or something, right? All the houses should have separate pipelines. See, all the houses, guys, should have a separate pipeline to access the tank. Okay. They have separate pipeline, right, to access the water tank or whatever resources. The same concept here. All these containers use a separate pipeline to access these things, say network, processors, mounts, and all, right? All these containers should have separate pipelines, guys, to access the resources, right? Say you can go for the Ubuntu, Fedora, SUSE Linux, or CentOS Linux, whatever it is, right? Say software or you can go for any software, MySQL, Docker, sorry, the database container, web server container, right? Blah, blah things. Docker is there. On top of Docker, we have different softwares, say Ubuntu, Fedora, whatever, SUSE, CentOS, MySQL, blah, blah things, right? Sharing the kernel, okay? Sharing the same kernel, right? Now you see here, this is the virtual machine concept. This is the Docker concept, guys. Here we go for the hypervisor. On top of hypervisor, we have separate VMs, guys. VM1, VM2, like that. Here, on top of Docker software, we go for the container, guys. It's the container. Okay. You can see the RAM utilization, blah, blah, the size of the storage, blah, blah, this. Later we see about the storage and all. Okay. So if you see here, the storage is in a GB size. Here, the storage are MP, guys, very less. Memory also very low, guys. And the boot up time also very speed. Compare with VMs, right? So because of this reason, people prefer Docker, right? So here we have the, say, virtual machine also we can install the Docker. How is done? See, say this Docker is floating over the water, guys. On top of water, this is floating. Okay. These containers are running, guys. These containers are running. Ansible is running. MongoDB is running. Redis is running. not yes, is running, right? So these applications are running, guys. Right? So if you want to create the container, guys, what you can do is Docker run and type call the image, Ansible, MongoDB, Redis, Node.js, Ubuntu or Debian, whatever it is. Likewise, you can run the containers, right? Container versus images. See, guys, this is the image, the static thing. Image won't run, it's static. These are the containers. From this image, guys, from the one image, we can create many containers from one image. Say, for example, one CD, we can install many computers. Using one image, we can install many computers, guys. The same concept. Say, using one image, we can create many containers. One image. Right? Many containers. Right? Container versus images. Right? Both are two different things. This one not run, but these things can run, guys. Right? Container editions, community editions, enterprise edition. Community edition, say Linux, Mac, Windows, Cloud, whatever it is. Say Docker commands. So these are the Docker commands, guys. Say if you want to create the container, say start the container, Docker run and the image name. Right? Say when you type like this, it will connect to the Docker, connect to the Docker hub. Right? It will connect to Docker hub and pull the image and create a container. Say here, Docker run Nginx. Says pulling the latest image here and create the container. All the containers should have ID, guys. Right? Say download a new image from Nginx, latest image. Right? If you want to list the containers, Docker PS. If you type Docker PS, you can list down the containers. Docker PS. Suppose if you want to list all the containers, just type PS minus A. What is the difference between Docker PS and Docker PS minus A is here you can see all the containers, including dead containers as well. Here see the first container is running up 6 seconds. See the second container Redis is dead. So if you type ps minus a all, here you can see all the containers. Okay, the running container and the dead container. Clear? So if you have any questions, please raise. So guys, if you don't have any question, we will start the practical now. Right? Fine. So let's start the practical. Say, let me go to the Amazon console and launch one or two computers. Let me launch one Linux machine. You can go for any flavors, say Red Cut, Ubuntu, Sushi, whatever it is. Say, right. One more thing, guys. One more thing. Before launch these things, say here, this is our computer, guys. This is our computer. The computer known as the special name Docker host. Docker host. Inside the computer, we are launching the container. Right? These are the container, guys. Docker, okay? The container. This is the container, guys. Right? Now see, let's launch it. Say, let me go for Ubuntu or someone, Ubuntu or something. Let's go with Ubuntu server 20.04. Say guys, what is LTS, guys? Long support version. Say for example, 6 months or 1 year, right? Long support version. Right, let's launch this one. This is my Docker. What is, guys? This is my Docker. Which one? This is my Docker. Docker. What is? It's a host or container. It's a Docker
host.
Good. Right. This is my Docker host. Huh? Right. Say, let me go for this hardware. Right. You can go for this as well. Huh? This is also fine. Right. We can go up to 30 GB RAM. Say, let's put 10 GB. Say, just put the name as Docker or something. Huh? Docker machine host. Docker host. We put the name. It's our Docker host. So let me create the new key. So this is my Docker host, the hardware machine, right? This is my hardware machine. So let me update this one. I just updated. Next one, guys, let me install the layer, Docker layer. See here. See here. Let's install the Docker layer on the top of OS. We are installing the Docker layer, right? Right. So just type apt install Docker. Just put -c. Okay. Right. It will install the Docker layer, and second thing, it will start automatically. It will start the Docker server automatically. Right? Look here. Just install. Now see here. See, just type service Docker status. The status also started automatically. See here, service Docker status. Now you can see the status. Says active and running. That means Docker service is running. Right. So we call this a Docker, the container engine or Docker or container engine. Right? Started Docker application container engine. This engine can hold or create the containers. It's a container engine. Okay, it will create the containers. Right. Now see here. Right. Now Docker is running. Now see here, first of all, we need images. We need images to run the containers. You see here. Let me show you something. Let's see the Docker architecture, guys. So let's go with this one. Look here. This is the Docker architecture. Say registry. Registry is like the repository. Say, for example, guys, hub.docker.com is one of the registry, guys. Right? Say hub.docker.com is the registry. Here you can see all the softwares. All the softwares. It may be operating system software or it may be application software. All the softwares, application software or OS software. Right? Is a registry, guys. Hub.docker.com is a registry where it shows all the images. It's a registry, guys. We are downloading the images to our computer. See, we are downloading. So we have downloaded 2 images, guys. Once the images landed or just comes to your computer, we have to create the containers from the image. Containers. One image, we can create multiple containers. Isn't it, guys? We can create multiple containers. One image. Right? Docker host is there. See the wording? Docker host means it's our computer. The client is there. Docker client. That means the commands. Say when you install the software, guys. Say when you install the software, Docker software, this client also get installed. It's also get installed, guys. The management, how we are going to manage the Docker, the commands, Docker build, Docker pull, Docker run. These are the management commands, guys. The client also get installed. Now see here, we are typing like this, Docker pull. That means we are going to download the images. Say when we type the command, it will contact the another server, Docker daemon. Docker daemon, guys. Docker daemon is running. See here. We see here Docker daemon is running here. Isn't it? Right? We just type Docker pull. The command hand over to Docker daemon, guys, here. Then it will contact the repository. That means hub.docker.com and download the images to your computer. These are the images. This is the service. We'll do that part, downloading part. We just give the command to the service. It will download the balance part. We are not directly downloading. The service is downloading. Daemon means service. The service is downloading to your computer these images. Now see, we just type like this, a Docker build. Docker build, the command hand over to Docker daemon, and it is building okay? It is building the images and all. Say the command hand over to this one, it will build the images. Right? Say Docker run, command hand over to Docker daemon, it will run the containers. It takes, say, once you type Docker run, the command goes to Docker daemon. Okay? It will contain one of the image and run the container. Run the container. Right? Clear, guys? So Docker host, we have images and containers, and we have the service. It will do all the tasks on behalf of you. You just type the command. It will do the balance part. Clear? Say if you type Docker run, the command goes to the Docker daemon. It will contain the image and run the image as containers. Docker pull command goes here. It will contact to the Docker hub and download the image to your computer. The service is doing the balance part, guys. And you may think, so we got the images here, we got the images. Now you may ask a question, how do we create these images, isn't it? So we have the images, guys. You see here, we have a number of images. Say, images are there. This is the image. From the image, we can create the container. Right? Say, how the image comes, guys? How the image comes? These images comes from a file, guys. These images comes from file. Here we are writing some coding. We'll see what are the codings and all. Once we write the code, then we build the images, guys. So here we use the wording build. From the file, we are building the images. Once the image comes here, then we are running the images. When we run, the container comes. Right? Container comes. From the file, we are creating the images. From the images, we are creating the containers. Clear? Now that's okay. That's what you see the command here build. Docker build is there. That means from the file we are creating the images. Once we create the images, we upload the images to Docker Hub. Anyone wants can use your image. Your image I can use. Right? My image you can use. Say here, I am writing a software and creating the image guys. Right? Then this image I just uploaded to the Docker Hub. Anyone wants, use my image. Use my image to create the container. Right? Something like this. When you upload, you can upload to the public part or private part. Right? So for any questions, so we are here, we just install the Docker software, Docker service is running. Right? Right. Say what is the command to run the containers? Sorry, what is the command to run the images? Docker run Ansible. Right. First of all, let me download the images. Let me download the images from Docker Hub. I am downloading. Say Docker pulling me downloading. Pull. Say let me download Ubuntu. Enter. Now see here, I am downloading the Ubuntu image. So say downloaded, the status downloaded completed. Now we have download. Say let me download CentOS. Say let me download say Redshift database or some say Redshift say sorry Redis not Redshift Redis Redis is a database. Say download. See the speed is it has been downloaded. All these things downloaded from hub.docker.com. Right? Who downloaded? Docker daemon downloaded. We just pass the command. Did the service connect to the particular site and download it. Right? Now we have download the images, guys. See here, you see here, Docker images. You can see the images, guys. We have downloaded 3 images, 3 softwares. You can see the size of the softwares. These are the small in size, right? Let me answer the question. Yes, very good question. That means, the OS is different. These things are different. Say when we download the operating system, say for example ISO file. The ISO file is huge, right? Say for example, say around 2 GB. But if you see here, Ubuntu or CentOS, see the size 200 31 MB and 77.8 MB. So here we are downloading the dependencies. See here. This is the Docker image. Say it's the Ubuntu Docker image. Yeah? Ubuntu Docker image. Here we are downloading the dependencies. Dependencies and the libraries. Right? And here we are downloading the kernel as well, right? Ubuntu kernel as well. Right? The kernel and the dependencies and the libraries.
Basically the runtimes, right?
Yes. Right? Runtime. Right? So, see, on the other hand, if you take the operating system wise, here we are downloading all the packages, right? The kernel, blah blah things. That's what the size is. The huge. The size is 2.2 GB or something. So this much of this is here. Say this Ubuntu is 77 MB. Here we are downloading the kernel and the dependencies and the libraries. Only the needed part only. Okay? These things are enough to run the Ubuntu software. But the softwares, the other softwares, we have to install separately. So if you want to install Apache separately. Right? The tools, blah blah, the commands and all install separately. Right? If it is a Docker image. Right? Docker image. Right? It's different from the ISO. ISO is different. It has all the things. Right? All the blah blah things. Right? The boot up files, the kernels, the softwares, configuration files, blah blah things, right? This one is different, right? Right? That's what the size is very low, guys. Only the 77.8 MB. So if CentOS is the size, right? Right? Now we have downloaded the images, right? Images are okay. Now see, now we are going to run the containers. Now we are going to run the containers. What is the command? Docker run, right? Now see here. Docker run Ubuntu. This is enough, guys. It's enough, right? Here, I would like to add some parameters. Say -IT interactive, right? Say Ubuntu is these things. Say I would like to go for bin bash. Say bash is a shell. Bash is a shell. Right. Now let's see some commands. You see here. We just install these things. You can stop the service. You can start the service. If you type Docker images, you can see the images, right? You can see the images, say Docker images. You can see all the images here. Docker images. You can search the images. If you would like to download, just type Docker pull image name, whatever image name, whatever Docker image name, Docker PS, Docker PS -a. If you want to run the container from the image, Docker run IT interactive and the image name bin bash. So these things are not must, say, okay. These things are the shell and all is not must, right? So these things are not must. Say this, yeah. I would like to go for the bash shell. Say, I would like to go for the bash shell. Now see here, I am in the Docker host prompt. I am in the Docker host prompt, guys. See, this is the Docker host prompt. Now see here. Now see here. Look at here. Let me run these things. If I run, I switch to Docker prompt. See, I am here. I am in the Docker host prompt. If I run the command, I just switch to the container prompt. Somewhere here. Somewhere here. You can see the difference here. Huh? You can see the difference, right? Let me enter. Now see, I just switch to a Docker prompt. The container prompt, sorry. I'm in the container prompt. Okay. See here, if I type ifconfig, it won't work. See, if I type ifconfig, it won't work. The reason is this is not the ISO image. This is the Docker image. If I install the particular software only, ifconfig will work. Normally ifconfig or whatever apt, whatever won't work out, right? If you want, you can install it. Right? Say when you install this, the dependencies and the libraries will help you to install additional softwares. Right? Here, guys, we have the dependencies and the libraries. These things will help you to install additional softwares, guys. That's what here we have dependencies and the libraries. Right? Here, ifconfig not works. Right? Now I am here. Now I am here, guys. Earlier, I am here. Now I just switch to Docker, sorry, container prompt. Now I am somewhere here, the container prompt. Right, container prompt. Right. Now see, you may ask the question, how do I get back to the host prompt? How do we get back to the host prompt? Somewhere here. What you can do is press Control So if you press Control P, Control Q, you back to the Docker host. Now see here, look at here, say let me type Control P, Control Q. The keyboard guys say, let me type Control P, Control Q. Now see, I just back to Docker host prompt. Now I am here. Now I am here. Clear? Control P, Control Q. If you type, then you back to Docker host. Right? Docker host. Now I am somewhere here, Docker host. Now if you type Docker PS, now you can see the running containers. Enter. Look at here. The container ID is there. The Ubuntu is an image. It's a command prompt. This is the switch Jackson. This is the container name. If you want, we can assign the name. If not, Docker will assign a name for this container. Right? The name as switch Jackson. Say it's running, say 4 minutes ago it's running. Okay, it's fine. So now we are here. Now we are here. You may think, how do we get back here? Right? Let me answer the question. Discussion. No. Right? Now see, if you want to go to the container, what you can do is, the container is running, right? Isn't it? It's running here. Right? Now see, we are going to attach. Now see, Docker attach and the name. Or you can use the ID or name. Say, let me use the name, Switch Jackson. Right? Enter here. Now see, we back to container. We back to container prompt. See the wordings, huh? We back to container prompt. This is the Docker host. Okay. The second time, if you back to the container, don't run the command like this. Clear? This is for only the first time. This is for only the first time. The container started, well, is running. Right? Now, if you want to access the container, Docker attach and the name. You see the command prompt, you can see here. The command is not here. This is the command. Docker attach switch Jackson. Right? Use the attach command. Right? Use the attach command, guys. Now we are here, guys. Now we are here.
The switch Jackson is a specific name for that particular the container, or is it a common one?
Yes, it's a specific name. If you run another container, it will assign the another name.
All right, okay.
Right? It will automatically assign the another name. It's a unique name for the particular container one. If you run second container, it will assign the different name, guys. Right? Say right. We'll see that one. Can we change the? Yes, we can change the name. We'll see, Oshan, right? We'll see. Now see here. Say now we are here, guys. Let's see the operating system. Let's see cat etc. Say what is the command to check the OS? Say, let me check one. OS release, OS release. OS release. Now I am running the command inside the container. Right. Now see, this is the Ubuntu 22.04 long-term support. Name Ubuntu. You can see blah blah things. Say, let me type ifconfig. Command not work. So what you can do is install the software for ifconfig command, right? Say, let me install apt install. First of all, update the container. Apt update, right? Now we are updating the container. It's updated. Let me install the software known as PT. I think NetTools or something. Wait, let me install NetTools and see whether. Yeah, NetTools. Now type ifconfig. Now it works. See, ifconfig is works. That means we just install the software, then we type the command. But OS, if you type ifconfig, it works really, right? Now you can see the IP address is there. Blah blah things, right? Right? Right. Now we are inside the container, right? Now see, someone type like this. Exit. Say he would like to exit, just type exit. If we say exit, back to here, back to Docker host. Now see carefully, right? Now see, let me type like this, Docker PS. Now can you see the container? What happened to the container? What happened, guys?
It's not running.
No, it's not running. Okay. Give me a second. Give me a second. So power cut. It's not running. Yes. Now let me type like this. Docker -a. I would like to see all the containers. You can so Docker. Sorry, I think PS -a. Yeah, PS -. Now see, you see the container now. See, the container is the status is exited. Is that a minute ago? Is that switch checksum is that right now? Dead containers. We can see the dead containers as Now see, now let me start the container again. Docker start. Just the container. So let me type the container ID right now. Now type Docker PS. Now she is running. Say Docker start. You can type go for the container ID or the container name. Now it started. Now see, you can see the container is running. Docker start, Docker stop, attach. The container is running. Now there's a requirement. There's a requirement to delete the container. Say type like this. Say Docker rm the container name. Enter here. Now see, there is complaining error response from daemon. Now who is responding to us? Who is responding? The daemon is responding, guys. This guy is responding. What he is telling? You can't remove the running container. Okay, these things. We'll see what is the number and all. Stop the container before attempting to removal or force remove. So if you want to delete the container, first of all, stop the container. Right? Docker stop. Now we are stopping the container. It will take some time. Now the container has stopped. Now just remove the container. Now say delete the container, right? Enter. Now the container has been deleted. Say just type Docker PS. You won't see the container. Say PS minus A is confirmed. It has been deleted. It has been deleted, guys. RM remove. You can see it has been deleted. Right. Now see here, let me create the container. Let me run the container again. So since it's the first time, right? It's the first time. It's the first time. What you can do is Docker run and just type the image name. This time, let me go with a different image, say CentOS or something. Right? We have downloaded this image. Interactive, we would like to go with interactive IT, right? Interactive, then go with the bin bash, right? Enter. Now we are inside the CentOS container is running. Okay. Say if you type exit, what will happen is the container will going to die. Container going to die. Don't type exit. Press Control P and Control Q in your keyboard. Say, let me type Control P, Control Q, Control P, Control Q. Now see, the container also running, we just back here. We just back to the Docker host. We just back to Docker host, guys. Okay. So if you type Docker PS, you can see it's running. Now it's come with a different name. Jolly Mercury or something. Say let me run Ubuntu. Let me run Ubuntu image, right? Control P, Control Q. Now, guys, we are running two containers. Now we are running two containers. One is CentOS. Other one is the CentOS one is running. Other one is Ubuntu. Also, we are running. Say then type Docker PS. You can see the both containers. Okay, different names. Say Great Fermi, Jolly Mercury. Different name. If you want, you can give a name as well. Say, let me go with Ubuntu. I would like to go with, say, the name would be, say, development or something, right? Or QA or whatever name, right? Say, asterisk, right? What is there? Execution of this name is executable file not found in the path unknown. Okay. Is complaining something wrong with the name keyword. It should be like this. Sorry, I made a mistake. Say put the name like this. Anyway, I'll check these things. Or just give name. Anyway, I'll check the command. We have to give, can give the name. Let me check the command prompt. Say dash IT dash name. Says correct, right? Docker run IT dash IT. Okay. The thing is, you just put these things up. You just put the name here, right? After IT, just put a name, development or something, right? So it works. Okay. Control P, Control Q. Docker PSNC. Now see here, our dev container is running, right? Blah blah things. We can change the name as you wish. Okay, let me answer the question. Yes, I'm not quite sure about MS SQL, right? But let me check. Let me check with Windows things. Let's see whether we can find the Windows images. Windows based images. You can see the Windows based images as well. Only the base OS. It doesn't have the GUI and all. Let me go for the, see, we have Windows images, WAS images, IoT images, see. So the server side images, blah, blah things, right? Yes, we have the Windows images as well. Let me go for Windows 2012 or something. Not these things, but we have some Windows images. Yes. Yeah, the official Windows-based images containers. Yes, we have the Windows images as well. You can download this one, right? Say Microsoft Windows or something. You can see the image description. What is these things? How this image works? Vehicle and hospital, Hyper-V isolation. Yes, we have Windows images also. Right? You can see the list these things, right? Yes, we shut down the container. So if you here, if you type exit or if you stop, we shut down the container. Right? That means shut down. We can start it. Right? We can okay. We can start it. You can see here. Right? We just if you type wait. Yeah, if you type yeah, we can shut down the Docker container. If you type exit or just stop the container, both will shut down the container. Say exit, right? Right. Now, right. Okay. Right. Okay. Now see here is running. Now Docker is running. Say, let me open this one. Microsoft file. Now you see here, this is the Docker host. Wait, give me a second. Wait. So this is the container somewhere here. This is the Docker host, guys. This is the container. Right. So in our computer Docker host, we have two network cards, isn't it? You see here, we have two network cards. You see here, say public IP address, private IP address, two network cards. So this is the public IP address, guys. You can see the private IP address. This is the private IP address. Let's see the container IP address. Say, let me go to this container. Let me access a dev container, development container. How do we access? Docker, attach, and the name. And the name, say dev. Enter. Now, guys, we are inside the dev container. A dev container. We just call a dev container, right? Right. Check the IP address, ifconfig. Sorry, ifconfig. It's not works out, guys. Say, let me update the container. Right. So let me install net tools. Now just type ifconfig. This is the container IP address, guys. Container IP address. Container IP, guys. Now, so the Docker, this Docker setup is in the bridge network, guys. Actually, right now, the Docker is in the bridge setup. You see here, say, let me press Control P, Control Q. I just back to the Docker host, right? Here just type Docker network ls, right? Clear, guys? Enter. Now see, say it's in the bridge. So we have three networks. Say one is bridge networking, other one host style networking, other one none. Right. Say let me type this command. Let me type this command. Docker inspect. Just inspect this bridge, right? Inspect this bridge. The name is their name bridge, right? Just type like this. Docker inspect. Get the inspection, right? Right? Try to get more detail, right? Something like this. Docker inspect the bridge. Now inspect, now type. Once you type this command, inspect command, you see number of options. Now see, this is the, what is the name of the bridge? The bridge name. This is the name of the bridge, guys. This is the bridge ID is there. When the bridge is created, the driver also bridge. This is the subnet is there. This is the subnet, guys, the bridge subnet. Is the subnet. Just copy the subnet and paste it here. This is the bridge subnet, not IP address. Subnet is different, IP is different. Don't be confused. Bridge subnet is there. Now let's come down. Some more. Now see, here the containers. What are the containers connected with this bridge? This is the default bridge. Say, let me get the name. What is the default bridge name? Bridge. Bridge is a name. Is the default name. You can change the name as well. This is the bridge name. Right? Say, wait. The bridge name. You see here, the container, say Great Femi, Jolly, Merkley, Adev. These containers are connected with the bridge. Now you can see the container IP address. Container IP address. You can see the container MAC address, IP address. The containers are the tiny computers, the small computers. It has IP address and the MAC address. IP address, MAC address. This is the dev container. It has this IP address and this MAC address. Just copy the dev IP address. This is the dev container. Just type the paste the IP address. Say the IP is there, right? The 04, the IP already there. 04 is the IP address. Right? Now, what is the bridge IP address? This is a subnet. This is the container's IP address. Bridge IP should be here. If the bridge IP is not here, what you can do is just type like this: IF control. if config, oh, wait. Here, you have to run this software, right? Do if config in the host prompt. Just type if config. You see here a Docker 0. This is the bridge IP address, guys. 172.17.01. The bridge IP address. Just is the bridge IP address. So the bridge and the container is the dev container is there. Dev container is there. This is the dev container IP address. This is the bridge IP address. This is the Docker host. Say Docker host IP address. Docker host, it has two IP address. This is the public IP address, private IP address. Docker host, it has two IP address, guys. A public IP, private IP address. Right? This is the IP setup. Now see, we all are outside. We are outside, guys. Can we access this dev container from outside? We all are outside. Now there's a requirement to access this container. Right? But we can access this Docker host. Just typing the public IP address, or then we can access the Docker host. Now the question is, can we access the dev container? Yes, we can access. If you want to access this dev container from outside, what you can do is, we have to go for a concept known as port mapping concept. Right? We have to go for the concept known as port mapping concept. Look here. This is the port mapping concept, guys. So this port 80 is mapped to the container port. Say port 8000 is mapped to container port 5000. 8001 is mapped to this one. Right? Clear, guys? So if you want to access the container from outside, you have to go for the port mapping concept. All right? Now look here. Let me open this. This is the Docker host. This is the Docker host, guys. This is the container. say the port is something like this, say 8080, something like this. Say, look here. So this port 80. 80 is the container port. 8080 is the Docker host port. Right? That means port 80 is mapped to 8080 in the Docker host. 8080 is a Docker host port. 80 is the container port. Clear? Now, let's map the port. Okay. Let me map the port. Before that, guys, just go to the server and copy the public IP address. Paste here. Let's see whether we can access the container. Here, guys, I just copy the Docker host public IP address. Just observe here. Can we access the particular server, Apache server or something? Okay, you may think the Apache is not there. Okay, go to the container. Say Docker PS. Here you can see the containers. Let me go to dev container. Dev container. I am inside the dev container. Let me install Apache. apt install Apache 2 or something. So here I just install Apache software. The software is ready. Let me start the Apache server. What's the command, guys? Don't worry about this. There's a similar error comes. Right. Now let's check the Apache status. Now Apache is running. Right? Let's access the server from outside. So just call the particular public IP address. The thing is, this IP is exposed to outside. If I want to access the dev container, I can't use this IP address. Since it's the private IP address, I can't use this IP address. I can't use this IP address. I only can use the exposed one, outside one, the public IP address. Let's type the public IP address now. It won't work out. I just type here. It's not work out, guys. So there may be a reason. There may be the Amazon firewall might block. Right? Amazon firewall might block. Now just go to the Amazon here. just enable the firewall. Go to the security. Say by default 22 is exposed to outside port number 22. Let me open port 80, right? So go here and just at the role, you just say here, I would like to open port 80 because I am running a web server, right? Say, let me open this one, HTTP 00, save, see, now save. Now the port 80 has been exposed to outside, it has been opened, you see here. Say, let me access the server. Still the wheel is running in the left, okay, left side. Say still we get that this side cannot be reached. Say we access this public IP address, we can access the server. Then we go for the port mapping concept. Let's go for 80. Right, 8080. Here, 8080 is the so guys, I made a mistake here. Here, wait. This 8080 is sorry, 8080 is a Docker host. The 80 is this port, the container port. 8080 is the Docker host port. 80 is the container port, right? Now, what I can do is just map the port. Just map the port. Let's see how to do it, right? Now, first of all, say let me what we can do is let's go for a new container, right? Now the dev container is already running, right? The running container, I can't modify the port, right? Say here, Docker PS also. Control P, Control Q, right? Say a Docker PS, you can see the running container here. The running containers, I can't modify anything. Right? So what I can do is let me create a new container. Say first time, say just use Docker run interactive. Say let me go for name. Say let me go for QA whatever thing, right? Say a dev bin bash, okay. Something like this. Docker run, right? Okay. The reason is I can't modify the parameters with running containers. That is the reason I would like to go for the new container, QA container, right? Now here, guys, say sorry. Now here minus P, just put 8080 80. I just map the ports. This is how we map the port -P 8080, right? So this the name would be, let me say the image is Ubuntu, right? Ubuntu is the image, right? And the QA is the name, and this is the port. Sorry guys, give me a second. Right? 80, right? Right. And the name, right? Blah blah thing, right? Now see, enter here. Now the container is running. What is the container name? QA. Right? Control P, Control Q. Right? Say Docker PS. You can see here the QA container is running. Now you see here. Sorry. QA container is running. You see here 8080 is mapped to port 80. This is the IP version 4. This is IP version 6. Right? We would like to go with IP version 4. Right? Right. Say, let me access the QA container. Say what you can do is say Docker is since it's the second time, just say attach a QA. Now we can access the QA container. Just install Apache over here. First of all, update the server. Sorry, update the container, right? apt update. Now we have updated the container. Now see, the container has been updated. Now let me install Apache apt. Let me install Apache. Yes, we would like to install Apache. Now we just install Apache. Once we install Apache, let's start Apache. Service Apache to start, yes. Now Apache has been started. You can see the status. The Apache is running. Now fine. Now, right. Now here, now this one 8080 is mapped to 80. That means here this port is sorry guys, 8080. This port is 80. Is mapped to 80, guys. So if we whatever traffic comes to 8080, it will forward to this container. Okay, whatever traffic comes here, it forward to somewhere here. The QA container, not dev QA, yeah? Sorry, QA container, isn't it? So this is the public IP address. This is the port number, right? Then we can able to access this container from outside, right? Now let's see. First of all, copy the public IP address. Copy the public IP address. We already copied. Say, copy. What is the port number? 8080, guys. Enter here. It should work now. Let's see, the wheel is running. Okay. I think then the port mapping need to be checked. Sometimes 8080. Let me check the issue. I think the wait minus Docker minus P 80 is mapped to 5000. No? I think it's other way around. See, I am wrong. The command here, guys, is other way around. Wait. Say 8000 is mapped to 8000 is so what I can do is 80, that means give me a second. The command is wrong, guys. That's the reason. In the container, VA software is not there. I'm installing the VA software. Something wrong in the port mapping, right? It should be other way around, right? 8080. So okay, guys, this is the command, the issue. So here, say minus P80 means the 80 is the Docker host port, and the 5000 is the container port. Here I put other way around. Say it's right. So it should be like this. It's wrong, right? So it's my mistake, guys. It should be put it like this. Say 80, it should map to 808, right? 80 means 80 is this port, right? Right. Let me change it, right? Let me change it. So what I can do is
So instead of changing the container port, can't you change the Docker host port in firewall?
yes, we can change. Yeah, yes, that is possible. Yeah. But there's an issue here that we can change. See here, we can change that. That is possible. right here. Even if we change, we can access it. Uh, now it's okay, right? So. Yeah, you are correct. Yeah. But here the issue is, the thing is, we just apply the command like this. It works now. We just apply the command like this. So 8080 is all right. Yeah. Command is okay, right? Command is okay. Yeah. This is correct. Yeah. Right. This is correct. Yeah. 8080 means this one is 808. Right. Command is okay. Yeah. Thing is the firewall issue. Firewall issue. Now we can access the Apache test case. Right. Now we can access there. Now we can access these. Right. We just call 8080. Right. 8080. Now we can access this. You are correct, right? Clear? Okay. Now we can access the content. Right? Yes. Right? This is how we access the containers, right? Clear? Now see, we can access these by calling 8080. Right? Right. Clear? You can see all the documentation and all those stuff here, right? Docker, say docs.docker.com. Right? This is the documentation and all, right? Right. Meantime, you can go for these tudes as well, right? Tudes as well, right? Now, this is fine, guys. Right? This is fine. It works, right? Now, we just design this sort of network in a different manner, right? Say, let me show you something. Let me design like this. Say, right. Let's design the network like this. Right. This is the Docker host. Okay. Here, let's see, we have number of containers. Say this is the one container is there. This is the another container is there. Okay. Right. There's another container is there. Right. This is the another container is there. So these containers get connected with the different bridges. Say this is one bridge. This is another bridge. Right. So this one is connected something like this. Huh? In the network card, Docker host network card. Here we have public IP address and private IP address. All those. Right. This is the container one, C1. So it's a container 2. It's a container 3. This is the user defined bridge, right? Say so user defined bridge one. This is the user defined bridge 2. So we can design our own bridge, okay, and set up the design like this. Previously, guys, see this, all these containers are something like this, right? All the containers are connected with the one bridge, right? Isn't it? Right? Now see here. Previously, say all these containers, say container 1, right? The container 2 or whatever containers, right? All these containers are connected with one bridge, huh? The default bridge. Something like this. What is the default bridge name?
Bridge.
Bridge, yes, good, right? Something like this, right? Container 1, container 2, all the containers are connected with one bridge. Now we go for the setup like this, guys. We go for the setup like this, right? Let's see how to design this sort of setup. Right? Now see here, say here, you see here, don't go here, and type like this, Docker inspect bridge, you see here. So the one bridge you see the all other containers are get connected. See, all are connected with the QA, whatever it is, connected with the one bridge, right? Clear? Right. So, right, this is the default setup. This is the default setup, right? This is the default setup, guys. Now we go for the setup like this, right? we create our own bridge. Sorry. Yes, we create our own bridge and connect this container to our own bridge, UDB1, UDB2, right? Set up like this, guys. Let's see how we are going to design this sort of structure. Say this is our Docker host, right? Here we are going to design like this. Clear? Right. So what we can do is we will go for the short break. Now the time is nearly 7:45. We will take 15 minutes break. Then we will start around 8, right? 8:85 we will start, right? Short break, huh?
Port
Yes.
map. So in the previous exercise, what we did was we just connected with port 8080, right?
8080, yes.
So if once we put 8080, are we in host, Docker host, or in the QA container?
Yeah, 8080 is the Docker host.
Docker host, right?
Yes.
Okay, then how can we access the QA? If let's say if we publish some website in QA container,
Yes.
how can we access that website?
Yes. No. Okay. Wait. Let me show you. Here. So here now see, first of all, we are executing this command in Docker host.
Okay.
Right. So we are here Docker host. So this port 8080 is the Docker host port.
Okay.
E is the container port. So we are here. This is the public IP, private IPs are there, and this, the bridge is there, right? Say the when the traffic comes here 8080, this one forward the traffic to bridge. It will automatically forward the traffic here.
Okay, so let's say we have another container with HTTP enabled. So then how can we differentiate the two containers?
Okay. All right. The container is HTTP enabled port 80. All right. Let's see. Let's see here. See here, all these ports are 5000. Say port 80 or something. Say port 80, same port. Here we change the port number. Docker host, we change the port number. Say 80, 8000, 8001. It will forward. Say if you call 80, it forward the traffic here. If you call 8000, it will forward the traffic here. If you call 8001, it will forward the traffic here.
Right. So that means if we have three containers in the Docker host, we need to create 3 ports for Docker host, right?
Yes, exactly correct. Yes.
Right. Thank you.
Separate, different Docker host port.
Okay.
Then it will forward the traffic here. Right. Okay. You just map like this. Say minus minus P 80 5000. This one. Say if you got 8000. Right. Okay. Right. Fine. Now let's design these sort of things. Huh? Right. See here. Say by default, all the containers get connected with the bridge, the default bridge. right? Default bridge name as bridge. This. So this is the user-defined bridge. So these sort of things we need our DevOps projects, right? This sort of setup, right? Right. Let's see how we are going to design these sort of things. Huh? Right. So just go here. First of all, let's create 3 containers, C1, C2, C3, right? Right. Let me create these containers. Say Docker run. Let me go with Ubuntu. Say interactive. Say let's go for the name is say C1, right? C1. Say just go with bin bash or something. I would like to go with bash shell, right? First of all, let's create the container C1, right? Control P, Control Q. So, sorry. Control P, Control Q. Say let's create another container C2. Control P, Control Q. Let's go with another container. Control P, Control. Now see, we have 3 containers C1, C2, C3. Right? Type Docker PS C1, C2, C3. Right? Now these are connected with the bridge, right? The default bridge. First of all, right? Say let's inspect bridge. Docker inspect bridge. Here you see all the containers C1, C2, C3 are connected with the bridge, right? Now let's create user-defined bridge, right? 2DB1, 2DB2, right? Say type like this, Docker network create -d bridge. The bridge name would be UDB1, right? This is how we create the bridges, right? Docker network create say -d and the bridge name, right? Sender. So now we have created this one bridge UDB1. Let me create UDB2. Let's say now we have created 2 bridges. Now these containers are ready. The bridges also ready, right? Right. Now see. Now, right now, these containers are connected with this bridge. First of all, remove these containers from the default bridge. Right, isn't it? First of all, remove these containers from the default bridge, right? Then connected with the user-defined bridge, right? That is a practice. So first we remove the containers. Here we use disconnect, disconnect bridge. Disconnect from the default bridge. I would like to remove C1, right? Enter. Now C1 remove. Let me remove C2 and C3. Now we have removed. Now we have removed these things from the default bridge. Okay. Now let's connect with the user-defined bridge, right? Docker network connect user-defined bridge 1 C1, right? Just put the container name, right? C1 is connected. C1 is connected. C2, one leg connected with the UDP1, other leg connected with the UDP2, right? Careful. Say C2, right? C2. Enter. It works. Now here, now let's go for the second bridge. It should be C2, right? The reason is, say, other leg connected with the user-defined bridge 2, right? Right. It has two connections. One connection with this bridge, other one with this one, right? Right. Now see, right. Just enter. Now UDP2 C2, right? Right. Now we have configured like this. Now we have configured like this. Let's check. Say Docker inspect UDP1. UDP1. Enter here. Now see here. Now we are accessing UDP. Sorry. Now we are accessing UDP1 bridge here. You see here the container 1 is connected. The container 2, one leg has been connected. Right? One leg is there. You can see the IP address, you know. This is the IP address. Right? Right. Let's inspect UDP2. You can see UDP2. Right? So you can see the IP address. It's a one leg IP address. Just get the gateway IP address. I mean, which IP address? Right? Now you see here. Here we have two different network. Say this portion is belongs to one network. Say 172.18.0/16. So this portion belongs to another network. 172.19.0.0/16. Two different networks, right? Right. So we need these sort of things for our DevOps labs, right? Right. So guys, so this one is completed. So if you have any questions, say, right? Say for here, say if you want to connect from C1 to C3 here, configure the routing between two network. Then you can connect from C1 to C3, right? Right. Okay. Right.
So when we do the port mapping here in this one,
Yes.
how many ports we have to create in Docker host? Is it only 3 or 4 ports?
Here, 3 ports.
Only 3, right?
Different. Say one. Say if we go for the port, say if we configure the port, say 808001. One time we go with this IP address. Other time we go with this IP address. One port is enough. Right?
Okay.
Right. Right. Here we have only 3 ports. 3 ports are enough, right? Right. So this is the small setup, right? Right. So far we are here, right? Just completed the port mapping. Other one is the volumes and all, how we are going to access the storage and all. Other one is there, how to check the logs and all. And networking part is there. This is the bridge networking. This is the host networking. Okay, this is the null, right? Right. This is it. The bridge. Sorry, this one is none. This one is host, right? Host, right? We are going to discuss this as well. This one we have completed. The bridge one. See the IPs and all, right? Right. Next time we are going to discuss the host port. What is host port? What is none? Right? These things. Right? Say. There are some storage drivers, blah blah, right? Say once we complete the Docker, next we are going to discuss the Docker file. What is the Docker file? How we are going to create the images from Docker file, right? Next one, we are going to discuss the Docker swarm, right? Right. Right. Next one, we are going to discuss the Kubernetes. It's very advanced, right? It's very advanced. Here, guys, we are assigning the IP address to the containers. Here we are assigning the IP address to containers. In Kubernetes, right? See the difference. Huh? Kubernetes, we are going to assign the IP address to pod. There is another concept known as pod concept. You know, see here. Say pod is something like say, how can I say this one? Say if you take papaya, say this one, there you see some seeds, right? Say, right? Say, papaya or something, right? Here, you see some seeds. So these seeds are like pots, right? So these seeds, see, the seeds are like pots, guys, right? Right. Now see, this is the Docker and some containers and all. Right? The Kubernetes is a Docker management software. Right? It's a management. The management known as orchestration. Orchestration, you know the in the musical guy, there's a person who managed the musical instruments, right? Say orchestration, right? Say or says let me put orchestration in music. So here, say this person known as orchestrate. See, this person known as orchestrate. This person manages others. He manages other person, right? Other, okay. So the Kubernetes is something like this. This Kubernetes is going to manage the containers. Okay? Is a management, some sort of management, right? The Docker is different thing. The management part is different thing, right? Don't be confused, right? Say Kubernetes, say these are the Dockers, say these are the Dockers guys. So this person is like a Kubernetes. Okay, Kubernetes. He is the one manage the containers, right? Right? The container management software known as Kubernetes. This is bit advanced. There are some complex concept there. Don't worry, we'll study those things, right? Right. Okay. Is the container management software, Kubernetes, right? Right. The Docker Swarm also container management software, right? Say here, guys. Docker is there. Sorry. Docker is a Docker, guys. Other one is there. Docker Swarm is also the container management software. Other one is there Kubernetes. Say it 1, 2, 3, 4, 5, 6, 7, 8. Kubernetes, right? See, both are Kubernetes. This is the bit advanced Kubernetes. KU Kubernetes. This one is bit advanced Kubernetes, right? Right. See now, this is equal to, say, some people call K8s. K8s. Say 1, 2, 3, 4, 5, 6, 7, 8. 8 letters. Okay. That's what people call K8s. Kubernetes or K8s, right? Right. 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 So guys, so we are in the Docker, right? We are in the Docker. So guys, any questions on this? So far, any questions?
So in the Docker Hub, all these images are free, or is it we need to pay for some of them, or is it free?
Yes, the uh, some are free, some we have to pay, right? So if you go for community version, sorry, community edition, those are free softwares. So if you go for enterprise and all, the paid one, right? You have to make the payment for enterprise softwares. So that's the thing. Right? Next class, we will see how to create the account in Docker Hub. Right? Once we create the account, we can push our images to Docker Hub, guys. Right? So here we can create, and let's see how to push the images to Docker Hub. Right? You can push on images. Right? So if you click update, say if you click update, say look at here. See, you can go for the other one. Say business, they charge this one, right? Say why now? You can go for the team or business, whatever it is, right? So these are the community edition, right? Say here you have the unlimited teams, 5,000 images you can store here, 50 concurrent build, unlimited image scan, unlimited scope token, blah, blah things, audit log. So these facilities not available in free version, right? At the time you build on only one image. Here you go for number of build, right? 15 say 15 concurrent build. 15 people can build at the same time, right? Okay, this is the community. This is a enterprise zone, right? You can see the free repositories. Just type. So these are the public. These are the public images. Anyone can use. Right? Anyone can use. You can search the repository, say a Red Hat. You can get the Red Hat repositories. There's no Red Hat. Say let's here you search, right? Okay. If you search here, you are searching inside your account, right? Search here, right? All right. Right. Here we have a number of Red Hat images, yeah, blah blah things, right?
All these are dependencies, right? Dependency.
Yes, yes. Dependency files and the library files here. Right? It's not the full image. The kernel and the dependencies. You can see these things and all. Better to go for the stars, the higher number of stars, huh? So you go for high number of stars. Okay, so this is the ideal, right? This is the ideal one. Yeah, there's like 0, 1, okay. This is the ideal one. Go with this one, right? So you have Linux, Windows operating system, blah blah things are there. Alpine is there. It's a very tiny image. Okay, a very tiny image. So hackers use this software, Alpine. You can see Python is there, Go language is there, Google language. Some sort of programming language, HTTP is there, Hello World, MongoDB, Debian, Registry, SonarQube is there, MariaDB, Amazon Linux is there. Right? You can see number of images. Right. So guys, next class also, we are going to discuss the Docker, the balance part, and we are going to move, we move to Docker Swarm. The another one is Kubernetes. It's a big part, guys. Right? Docker Swarm, Kubernetes. It's a very big part, guys, right? So then, guys, if you have any other questions today. Right. So guys, if you don't have any questions today, then we are going to wind up the session. Okay, then guys, goodbye, good night.
Thank you and good night, sir.